Alright, welcome back guys. We're going to be looking at the support material for section 2.2. Okay, so the first thing we're going to talk about is called combining like terms, or working with like terms. Okay, so let me give you an example here. If we have some kind of algebraic expression, I'll say 3x squared, or 3x to the second power, plus, we'll go with 4x minus 1, and then on the other, let's continue, maybe have a minus just x squared, and then a minus 2x, and then a plus 3. So this expression here actually has 6 terms. So the terms, guys, are basically the pieces that are separated with addition. And you may say, well, right here there's subtraction. Well, this minus 1 really is the same as plus negative 1. Okay? And the same thing for this minus x squared. It's really the same as plus and then negative x squared. So basically, each piece here is a term, so we've got 6 terms. So what we want to do is look at how can we simplify an expression like this by combining what are called like terms. So it says if 2 terms have the same variable factors, we say that they're like. And then if 2 terms are simply numbers, they are also like terms. When they're both numbers, guys, they're called constants. So let's look at this example. I'm going to grab a different color. I'm going to underline my like terms. This first term, 3x squared, is like this other negative x squared. And the reason is because these both have x's, both of these terms, and the x's are both raised to the same power. So these are like terms. And by the way, there's not a number in front of this x squared term, but we could put one there if we wanted. There's always going to be an understood 1. Okay? So it's like there's a little negative 1 sitting in front of that x squared. And then some of my other like terms here are going to be the 4x and the negative 2x. Okay, those are like terms because they each have exactly 1 factor of x. And then finally, I have what we call 2 constant terms, the negative 1 and the positive 3. These are like terms as well. They're both just constants. That's what we call them. The other terms are called variable terms. So what we want to do is we want to combine our like terms. That's how we simplify these algebraic expressions. So let's look at some examples. Say, example 1, it says simplify to form an equivalent expression by combining like terms. So I've got this expression right here. It only has 2 terms in it, 7x minus 10x, but these terms are like because they each have 1 factor of x. And so the way you do this, guys, is you work with the coefficients. The coefficients are the numbers in front of the variables. So we subtract the 7 and the 10. So you basically say 7 minus 10 is negative 3. So you put, let me get back to blue here. So you put negative 3, and then you just carry over that x. This is sort of like adding, say, apples and oranges. You can't add apples and oranges because they're 2 different types of fruit. So they're sort of like unlike terms. But if you have a whole bunch of the same type of fruit, say if you've got 2 apples here and then 7 apples over there, you can add those 2. You can say 2 plus 7 is 9, so you have a total of 9 apples. And so just like here, 7x minus 10x gives us negative 3x. Alright, now what about the second one? Here we've got 3 terms. We've got 15a plus, remember there's an understood 1, so 15a plus 1a minus 9a. Well, the way you can do this, since these are all like terms, they all have just one factor of a, you can just say, you can just figure out what 15 plus that little understood coefficient of 1 minus 9 is. So 15 plus 1 is 16, and 16 minus 9 is 7. We've got to keep that variable. Okay, so 15a plus 1a minus 9a is 7a. Alright, now look, it says like terms do not have to be side by side in an expression to be able to combine them. So if you look at that original example, the like terms in this example are not side by side, but we can still combine them. I could combine the 3x squared with the negative 1x squared. 3 minus 1 is 2, so that would become 2x squared. And then I could combine my x terms. My 4x minus my 2x would be 2x. And then finally I could combine my two constants. My negative 1 plus my 3 would give me a 2. Okay, so they don't have to be side by side, and many times they are not. Alright, now let's continue. So now we're going to be looking at something called the distributive property. So you may have heard this before. It basically occurs when we have an expression like this. I'm going to rewrite it. You have a 7, and then directly beside it you have in parentheses something like 4x plus 2. So what's occurring here is this 7 is getting multiplied to whatever's in these parentheses. Okay, and so you think, well, the order of operations, it says that we need to combine whatever we have in parentheses first. The problem here, though, is, guys, these are not like terms. We cannot add 4x and 2 because one of them has an x, one of them is a variable term, and the other one, the 2, is a constant term. So we can't actually add those. So what we have to do is we distribute the 7. Since the 7 is getting multiplied to everything in these parentheses, since we can't combine what we have in parentheses first, we just go ahead and distribute the 7. Okay, that's why it's called the distributive property. So basically what you do is you multiply the 7 to both of those terms. So you say 7 times 4x. So when you're multiplying, you just multiply the coefficients. 7 times 4 is 28, and you keep the x. So 28x. And then you multiply the 7 to the 2. And this is a positive 2. So 7 times 2 is positive 14. So I'll put plus 14. Okay. And at this point, this is all we can do, because we're left with these two terms, but they're not like, so we cannot combine them. So you can use the distributive property to distribute a number to terms inside parentheses that are not like. And that's what this basically says in the box right here. So here's another example. You can see in parentheses we have an x and a minus 2. And so you can't subtract 2 from x. Those aren't like terms. So what we have to do is just distribute the 4. So we say 4 times x, or 4 times 1x, same thing, gives us 4x. And then 4 times this negative 2 gives us the negative 8. Okay, so we're distributing whatever number's in front of these parentheses to the terms that are inside the parentheses. Now I do want to mention one thing right here. You can use the distributive property in reverse, and this is an example right here. So if you had, let's say, these two terms, 8x plus 8y, if you notice, each of these two terms have coefficients of 8. So what happened was an 8 was already distributed to these two terms. That's why they each have 8s. So you can actually take out that 8. So you're doing the reverse of the distributive property, and this is something that we call factoring. And we'll discuss this more in detail later. So basically you would take the 8 out, and then you would just rewrite whatever's left. So if you took the factor of 8 out from the first term, you just have an x left. And if you factor out the 8 from the second term, you would just have a plus y left. Okay. And then you could go back and distribute the 8 and see if you get the same thing. So that's actually called factoring. Alright, but let's get some practice using the distributive property. So example 2 says find an equivalent expression without parentheses. So notice in these parentheses we have two terms, but they're not like. We've got x and then minus 3. Okay, so we cannot combine those. So then you say, well, how can we use the distributive property if there's not a number in front of the parentheses? There's just a negative sign. Well, there is a number, and it's an understood 1. Okay, so anytime you see just a negative like that, know that there's also a 1 with it. So really what we'll be doing is distributing negative 1 to both of those terms. And guys, I want to point out, anytime you multiply something by a negative or by a negative 1, same thing, it changes its sign. And that's what's going to happen here. So when I multiply, or when I distribute that negative 1 to these two terms, that will change the sign of them. So negative 1 times x will become negative x. You could technically put negative 1x if you want, but it's not necessary. And then finally, look at this like it's a negative 3. So when you say negative 1 times negative 3, those two negatives, when multiplied, become a positive. Give us a positive 3. So our new expression is going to be negative x plus 3. Okay, example 3. Very similar. It says simplify to form an equivalent expression by combining like terms, and it says use the distributive property if necessary. Now I'm looking at this thing and I notice I sort of have 3 terms here. The issue is I cannot combine the 7b with the 3b, at least not yet, because this 3b is still in the parentheses. It's trapped in those parentheses, so somehow I need to free it. So what I'm going to do is use the distributive property. But the issue again is I'm not distributing the 7b, I'm distributing the negative 1 that's understood to be here. Okay, so I'm going to rewrite this. 7b minus, I'll put my little understood 1 there. And then plus 10. So the first thing I'm going to have to do is distribute that negative 1. And this is very common. When you're simplifying an algebraic expression like this, if you have parentheses in it, and there's more than one term in those parentheses, and you cannot combine the terms, chances are you're going to have to distribute something through those terms before you can take away the parentheses. So what I'm going to do is distribute the negative 1 to both of those terms. So when I do that, the 7b at the beginning will stay the same. And so if I multiply right here, negative 1 times 3b, that's just going to change the sign to negative 3b. And then negative 1 times 10 will give us a negative 10. Okay. Now that those parentheses are gone, since we utilized the distributive property, now we can actually combine our like terms if we have any. Well, in this case, guys, we do. And they're actually side by side. We've got 7b minus 3b, which would become 4b. And then we've got the constant minus 10. So you just bring it down, and that's as far as we can go. Because at this point, these two terms are unlike, so we cannot combine them. So we're going to have to stop there. But you can see we did simplify this original expression. You know, we turned it into essentially 3 terms to 2 terms. Okay, let's look at these last two. Very similar. Simplify by removing the parentheses and then collecting like terms. So notice this expression, it's longer, but it does have parentheses. And inside those parentheses are these two unlike terms. So that's my cue to use the distributive property here. So what I'm going to do, I'm going to rewrite the 4m, and I'm going to distribute the -5. It's the -5 that's getting multiplied to those two terms in parentheses. So -5 times 2m will become -10m. And now look at this like it's a -1. -5 times this -1 is going to become a +5. And we don't touch the -7, so just bring it down. Alright, so now that I've gotten rid of the parentheses, now what I'm going to do is look for any like terms that I can combine. Well, I see these first two, they both have m's. 4m minus 10m is going to give me -6m if I combine those. And furthermore, guys, we have a couple constant terms. We have a +5 minus 7, and that would give us a -2. So the answer, or the simplified expression, is going to be 6m minus 2. Alright, let's do this last one. Now it's got fractions, but let's not let that scare us. Now you can see in this case we have two sets of parentheses. I've got a set here, and the 1/4 is being distributed, and then I've got a second set in which the -1/3 is being distributed. So this is where, you may want to use your calculator. So I'm going to start by distributing the 1/4. So I'm going to multiply 1/4 to both of those terms. And I will grab my calculator. Let me show you how to do this by hand though real quick. The 1/4 times 16x. 1/4 times 16. To multiply fractions, guys, you got to make the 16 a fraction by putting it over 1. And then you multiply straight across. So 1 times 16 is 16. 4 times 1 is 4. And then you'll divide these if you can. 16 divided by 4 is just 4. Okay? So 1/4 times 16 is 4. So that's going to give 4x. You got to keep the variable. But now when we multiply the 1/4 to the -4, I'll do this one on paper as well. 1/4 times -4. Put that 4 over 1. And go straight across. 1 times -4 is -4. 4 times 1 is 4. And -4 divided by 4 is -1. Okay? So that's just going to become a -1. Another way to look at that is, I showed you this in class, is you could say, well, this 4 right here is in the numerator, this 4 is in the denominator, so wouldn't those just divide out? Or in other words, they divide out and give you a -1. And then -1 times the +1 that's right here gives you -1. Okay, so let's continue. Now let's distribute the -1/3 to the second set of parentheses. So -1/3 times -6. You could do it the same way. -1 times -6 is +6. 3 times 1 is 3. And 6 divided by 3 is 2. And since that 2 is positive, I'm going to put a plus 2x. Okay, remember, you've got to keep your variable. And finally, guys, the -1/3 times the -9 right here. This is where I will take the shortcut. I got this negative 9 in the numerator. I've got this positive 3 in the denominator. If I divide those two, negative 9 divided by 3 is negative 3. And negative 3 times that negative 1 will be positive 3. Okay, so plus 3. And finally bring down that last constant, which is a negative 8. So check these in the calculator if you need to. Okay, let's check that last one. We had negative 1/3 times negative 6. We got 2x. There's another way you can use the calculator. You can hit alpha and then the y equals key. And it'll allow you to put in the fraction in fraction form instead of a division problem. So this n and d here represent numerator over denominator. So if I click on that, I can actually type in, I could put the negative 1 over 3, and then I could say times, whatever. Let's do the negative 9 now. Times negative 9, hit enter. The nice thing about this is that if your answer were going to be a fraction, it'll give it to you as a fraction. If you type it in the other way, the way I did the first time, it'll give me my answer as a decimal if my answer is a fraction. Okay, so a couple ways to do that. Alright, well in any case, we have distributed those two fractions. We no longer have parentheses. So now what we're looking to do is combine any like terms that we have. So it looks like I see a couple x terms, which I'll highlight, that we can combine. A 4x and a 2x, they're both positives. So that's going to give us 6x. And then lastly, guys, it looks like we have several constants. We've got a negative 1, positive 3, and a negative 8. If you were to combine all of those, what would we get? I want to say negative 6. Okay. Yeah, we would get negative 6. So we had three constants. When we combine those, we get negative 6. So our simplified expression is 6x minus 6. And these two terms are both unlike, which means we cannot simplify this expression anymore.